province. Okay, this time round, there is a cute presentation where the question paper is merged with the answer book. That is fine. We shall see how we can do. Question number 1. They're telling us that a table below shows the monthly salaries of 100 employees at that law firm. Okay. Then 1.1, they want us to draw an ogive to represent the data in the table. So step number 1, what we need to do is we need to first of all complete the cumulative frequency column. Okay. And if that can be done, then we shall be in position to draw our ogive or cumulative graph. So first cumulative will be a 3. Then 3 plus 4, that's going to be 7. Then 7 plus 13, that's going to give us a 20. 20 plus 20, that's a 40. 40 plus 21, that is a 61. And then plus 12, that's going to be a 73. Plus 12, which is 85. 85 plus 8, that's going to be a 93. And then a 98. And then lastly, we have 100. So those are the cumulative values that we needed. Okay. Then we go down and plot the graph. Remember, when you're plotting, we always look at the upper class intervals. These ones. They are the ones that we use against the cumulative. Let me just use a red one. Okay. So it's saying 0 is going with 3. 0 goes with 3. No, not 0. It's 10. 10 goes with 3. So if it's 10 rands or 10,000 rands, those are 3 threes somewhere there. Okay. Then 20, we say it goes with a 7. 20 is a 7. So let's locate where 7 is, slightly above the 5. Okay, then 30, we say it goes with a 20. This 30 here must go with a 20, then a 40. Okay, 20 is there. Then a 40 for 40. Okay. And then we said we have 61. The next one must be 61. 61 is slightly above 60. Then 73 for the next one, slightly below 5. And then we have 85, which is exactly in the middle there. We have 93, which is slightly below. Then 98, somewhere there. And then we shall have 100, which is at that point. Okay. Then from there, what we can do is just connect the dots so that we get the S kind of graph. Okay. So if I use my dotted lines, I'll start with the dotted lines and have, no, let me just connect it once. Okay. So something like that. Connect this to that. Okay, let's remove this and reconnect it again. And then we connect this to the original class interval, which is a 0. Okay. All right, so this is our cumulative graph that they needed. Then question number next. Question number next, what do they need? They want us to use the ogive to determine the number of employees that received less than 35,000. Okay, so for us to get 35,000, come to the salaries. We come to the salaries and look for 35,000, which is halfway here. Then let's draw a line up until it meets the ogive. Okay. It's saying we are drawing a line from 35,000 up until it meets the ogive, and then we read the value on the side. So we have 30 people altogether. Okay. So that's going to be 30 employees. All right, then next question, determine the median. So for us to get the median, we know that we have 100 employees, so we need to get a half of 100, or you can say half of 100 plus 1, which will give us a 50 or 50,5. Then let's look for 50,5. I'm going to just look for 50. So this is a 50. Follow this line of 50 up until it meets the ogive somewhere there, and then let's take the reading. So this represents the median, which is 45,000. Okay, so median data will be 45,000 rands. Okay, 1.4. They're telling us that the monthly salaries of 5 employees within this interval are listed below. Then 2 employees from one other interval were promoted and are receiving 83,000. And then they're also receiving 84,000, which is somewhere there. Then the question is asking for the monthly mean. So if you punch this into your calculator using the start functions, so that's 83,000. We have another 84,000, then 84,000. We have 85. Then we have 87. We have 89. And then lastly, we have 89. Okay, perform the functions. What do we need? We need the mean. So the mean becomes 85,857,142. Okay, and then they want us to get the standard deviation. So shift 1, 4, and then 3. I'm having 2294,63. Okay, 2294,63. So that's my standard deviation. Then 1.4.3. They want us to get the percentage of employees whose monthly salaries lie within one standard deviation. So let's get the interval of the mean minus the standard deviation, and then the mean plus the standard deviation. So if it's 85,857,14, we subtract the 2294,63. That's for the minimum, and then for the maximum, it's going to be 85,857,14 plus 2294,63. So my interval is basically 83,562, because this 85,000, it is going to be 83,000, okay? That's 51. And then the upper limit is going to be 88,151,77. Okay, so after getting this interval, then I need to count how many data pieces. Remember, I'm dealing with 7 data pieces and no longer 5. Okay, so above 83,000, so I have this one, the 84. I have the 84, I have the 85, I have 87. 89 lies above or outside. So it's 1, 2, 3, and then 4. Determine the percentage of employees. So since we're looking for percentage, we're going to have 4 over 7 times 100. Okay, 4 over 7 is giving me 0.57, which is now 57.14%. So that's what the question was asking for. Now remember, this is just a proposed memorandum. Memorandum is yet to be out. Okay. Let's look at question 2. Question number 2. Question 2, we have the bivariant. During a netball tournament, we have several stalls that's selling food and refreshments. In a period of 10 minutes, at 6 stalls, the following were observed. So we look at the number of customers and then the amount of money that was spent. Okay, we can show this information. And then we have our scatter plot drawn for us. And then the first question is asking for us to determine the equation of this regression line. Okay, so if you follow through with how this is done, using the mod start, and then you look for the AX plus B, which is option, I think, number 2, and then just feed the data into the calculator, and then look for the values of A and B. So we know that the general equation of the regression line should be given as A. It's a small a, capital A, it doesn't matter, plus bx. Okay, so from my calculator, I'm getting A to be 12,596. Let's just make it 12,60, plus the B, which is a 17,33 x. So that is the equation. Then predict the amount of money that is spent by 11 customers. So the customers in this case are representing the X. Okay. And then the amount spent is representing the Y. So since we're looking for the amount of money, which means we're looking for the Y, which is 12,60 plus 17,33 into 11. When I punch this into my calculator, I'm getting 203,23. So this is how much will be spent by 11 customers or clients. All right, then next one, they're telling us to determine the correlation coefficient. So still, when you use your data and calculator, I'm getting the R of 0,9. If I round it off, I'll have 9.5. Okay. Then the organizers of the event think that there is a very weak positive correlation between the number of customers and the amount of money that is spent. Motivate whether you agree or disagree. Okay, number 1, I will disagree with the fact that this weak whatever definition is wrong. When I look at the correlation coefficient of 0,95, this is a very high positive, or it's a very strong positive correlation. Say agree or disagree. It is a strong, or we can say very strong, positive correlation. Positive correlation. Okay. Alternatively, when you look at the points, yes, they're a bit far away, but that wouldn't define anything because the closeness would probably look at the correlation value. Okay, the points are not far apart. They are just close to each other. All right, so that is 2.4. Then 2.5, we have another store that is having 6 customers that spent 195. If this point is included in the data, will the gradient of the least square increase or decrease? Okay, so if I look at 6 and 195, so 6 is somewhere here, 195 is somewhere there. So in other words, this point is going to be an outlier, okay, compared to all the other pieces of data. And the fact that it is moving towards the y-axis, it's going to affect the gradient, okay? So if this point is included, will the gradient increase or decrease? Motivate your answer. So if it's going to attract the least squares regression line towards itself, which means the gradient becomes smaller, it's getting flatter and flatter. So my argument is going to be decrease, okay? Why? Because 6 and 195 is an outlier. This is an outlier that changes the gradient of the least square or of the regression line towards itself. All right, so that is 2.5. And then we look at 2 point, no, that is just the end of question 2. Let's look at question 3. In the diagram below, we have P, which is -9 and 12. Q is 9 and 9, are vertices of a triangle. M is the midpoint. I need to highlight this, of the line QR. N is AB, is a point on PM. Okay. In the second quadrant, the equation of QR. Okay, this equation is given as 2y minus 3x plus 9 is 0. The angle of inclination of QR is theta. Good. And then they ask us to calculate the coordinates of M. So we know that M is on the x-axis, or it represents the x-intercept. Under the x-intercept, we know that y will always be a 0. So what I'm going to do, where there is y, I'll put a 0. So that's going to be 2 times 0 minus 3x plus 9 is a 0. So negative 3x, let's move the 9 to that side, is negative 9. Divide both sides by negative 3, which means x is a 3. So the coordinates of M are basically 3 and 0. Okay, we move on to the next question. Next question. So remember, we say this is a 3 and 0. Okay, next question they're asking us, determine the equation of PM. Let's look at PM. PM. So we have this point M, and then we have this as well. So we can find the gradient. Gradient of PM will be change in y over change in x, which is a 12 minus 0 over negative 9 minus 3. So it's 12 over negative 12, which must give us negative 1. So if the gradient is negative 1, we can use the point 3 and 0 and say y minus y1 is equal to m into x minus x1. Substitute into that formula. Y minus 0 is equal to negative 1 into x minus a 3. So y becomes negative x. That and that gives us a positive 3. So that becomes the equation of PM. And then they want us to get the size of theta. Okay, we need to find the size of theta. So what we're going to do here is we need to find the gradient of QR. Okay, from this equation, we can find the gradient, or you can use these points Q and M. You get the gradient. So gradient of QR, we're using 9 and 9, then we have 3 and 0. So it's 9 minus 0 over 9 minus 3, which is a 9 over 6, which is by 3 is a 3, by 3 is a 2. Then we know that the tan of theta should be equivalent to M, which means M. We have our M as 3 over 2. So which means for us to get the theta, let's do the substitution. It's going to be the shift tan of 3 over 2. Okay. Shift tan of 3 over 2, that's giving me 56.31 degrees. Okay. So if this is a 56.31, let's look at the next question. They want us to show that B. They want us to show that P is given as that if P, N, and M are collinear. So collinear simply means that the points are just lying on the same straight line. And for as long as points lie on the same straight line, the gradient between P, N is the same as the gradient between N, M, and the same as P, M. So I know for sure that the gradient here, because the question asks for the gradient, we got a -1, not so? Gradient of PM. So I can use, let me use N and M. Okay. So N is AB, M is 30. Let me use this and equate it to the gradient of -1. So I'm going to say change in Y over change in X. So it's going to be a B minus 0 over A minus 3. This must give us negative 1. Cross multiply. So B is going to be negative A plus 3, or the other way around, 3 minus A. Okay, so that is 3.4. Then 3.5. 3.5, they're asking us to hence determine A and B if NQ is 5 root 5. Where is NQ? So from here up to here, that's a 5 root 5. So since I already have my coordinates of B, or my value of B, remember the previous question told us it's a 3 minus A. So let's use this, substitute into that using the distance formula. Okay, so I'm going to say that the distance NQ is given as the square root. I'm going to have 9 minus A squared plus, can still have 9 minus 3 minus A. This must be squared. Let's substitute. So 5 root 5 is giving us the square root of, let's open this up. That's going to be 81 minus 18A plus A squared. Simplifying this in the brackets will just give us a 6 plus A. Let's open that up. 6 squared is a 36 plus 12A plus A squared. Let's square both sides to get rid of the root sign. So if I square that and square that, that's going to be 25 times 5, which is 125. How many A's are there? There are 2 A's. Minus 18 plus 12, that's minus 6A. 81 plus 36. Okay, that's giving me 117. Let me move the 125 that side. 2A squared minus 6A. That's going to be a minus 125 minus 117, which is 8. This must be equated to 0. Okay. Divide through by 2. A squared minus 3A minus 4 is equal to 0. Okay. Then let's get the factors. Let's get the factors. That is A minus 4, A plus 1, which means either A is a 4 or A is going to be negative 1. But looking at the position of A, okay, looking at point A, which means our A has to be a negative 1. Okay, so if that is true, we're going to substitute this into the formula of B. So which means B is going to be 3. Remember we said it's a 3 minus A. So it's basically 3 minus 1, which is a 4. So A is negative 1, and then B is going to be a positive 4. So basically, that is what we would have obtained if we were to look for the values of A and B. Then 3.6, they want us to get the equation of the circle that is having O as the origin. Okay, let me use a different color. So if O is the origin, and this circle must pass through point R, please, that's just the imaginary circle that I have. So which means if we can get this distance, OR, that's going to be our radius, okay? But for us to do that, we need the coordinates of R. Remember, they told us that M is the midpoint of the QR. Okay, so 9930. So we have 99, we have 30, then we have R, which is XY. So that's Q, M, and R. So we know that from our midpoint formula, if we get X plus 9 divided by 2, must give us this 3. Cross multiply, X plus 9 is a 6, which means X is going to be a negative 3. Is that true? Yes, R is in the third quadrant where X is a negative. Perfect. Let's do the same with the Y. So Y plus 9 divided by 2 must give us a 0 cross multiply. Y is a negative 9. So which means the coordinates of R are basically negative 3 and 9. So for us to get the distance OR, we need to find the square root of 0 minus 3 squared plus 0 minus 9 squared. So that's going to be 9 plus 81, which gives us a square root of 90. And then from the equation of a circle, we know that this should be the general equation where A and B are the coordinates of the center. But we know that A and B are 0, so it's just going to be x squared plus y squared is equal to the root 90 squared, which is just a 90. So this is what the question wanted. Or alternatively, you can pull the 90 that side, you have x squared. Okay, let's see, you have x squared plus y squared minus 90 is equal to 0. There is no harm with this. So both answers will be correct. So that is 3.6. Then 3.7. 3.7, there is an acute angle between QR and another line, mx plus 4, that is 45. Determine the possible value of values of m. Okay, so let's see. So if we have a line whose gradient we don't know, but the y-intercept is a 4, which means that line is in this sort of direction. I don't know where the lines are meeting, but let me just assume they're just in that sort of direction. Let me just erase out a few things. Let me take this out. Okay, so what they're telling us is that this angle here is a 45, because if I look at this other angle, it's going to be way bigger than acute. Okay. So we know that the y value is a 4. That's why I'm choosing that direction. Because someone also choose a different direction, but for as long as positive 4, this is the only possible option we have. So y is mx plus 4. When I look at this question, it's 4 marks. What are we going to do? So since initially we got our angle of inclination to be 56,3. This is my thought, okay? And I beg to be advised just in case I'm wrong. So if I try to get this entire angle, so that I look at the angle of inclination and find the gradient, I think that would make sense, because it simply means that I'm going to have 1. So I'm going to have this 56 plus the 45. Okay. So I'll go down and say that 56,31 plus the 45 plus the 45, that gives me 101. Okay. It's giving us 101,31 degrees. So let me call this a T A and X. So TKX will be that. Now for me to get the gradient of this line, remember it's sloping downwards, which means it's negative. Then I'll say M is equal to the tan of theta. So for me to get the gradient, I'll use the tan of 101,31. Punching this into the calculator, I'm going to have -4. Okay, let's see. We're having -4,9999. How many nines? There are 4 nines. Then 6 9, which is approximately -5. There are no other values that I can think of. Okay, so if the gradient is, sorry, the y-intercept is a 4, then we definitely expect to have one particular value, which is a -5. Guys, that would be my approach, okay? But I beg to be liberated, just in case it doesn't make sense. All right, then the next question. Next question, they are telling us, they drew for us this shape, okay? And then what do they want us to do? Oh, they wanted us to use it. Okay, no stress. No stress. We're done with that. All right, so that was question number 3. Then question number 4, are telling us that in the diagram, the equation of a circle that is centered at B is given by x plus 1 squared and then plus y minus 1 squared equals 20. DF is a tangent, beautiful, at A, D, and F. The x-intercept, the y-intercepts respectively, okay. There we go. C is -1 and 6. Okay, point on BF with BC, that is parallel to the y-axis. And then this angle is a theta. Okay, so that's a theta, even this one is a theta. Beautiful. They want us to get the coordinates of B. Okay, so for us to get the coordinates of B, what we know, okay, what we know is that if this is I don't know, let's just get them from the equation of the circle without wasting time. So it's -1 and 1, period. Because we can get them from there, extract them straight away from there. Then 4.2, can we show that AC is square root 5? Show that AC, this distance here, is given as the square root of 5. So since we have this at 20, this 20 represents our r squared. So we need to find the radius itself, which is going to be the root of 20. I'm not going to simplify it. Let me leave it there like that. Then if the points here are -1 and 1, okay, let's get this off. We say -1 and 1, we can get the distance of BC. And since the line is part of the y-axis, which means this is 5 units. Because it's 6 minus 1, which is 5, okay? Then we can find our AC using the theorem of Pythagoras. Why are we using the theorem of Pythagoras? Because we know that DAB is going to be a 90. Because this is tan perpendicular to the radius. So I'll start by saying DAB, okay, DAB is a 90 degrees because tan perpendicular to the radius, okay. Then we said BC is 5 units. So for me to get the AC, if I use my Pythagoras theorem, this is going to be the longest side, which is 5. So it's going to be 5 squared minus root 20 squared. This must be under the square root sign. So we know that 5 squared is a 25, root sign falls off, minus 20, and then that gives us the root of 5. So that is 4.2. Then 4.3, they want us to get the value of theta. Okay, 4.3, we must get the value of theta. Not theta, tan theta, the tan of theta. So since we've got this as a root 5, we know that the tan of theta is the opposite of adjacent. Okay, so our opposite is a root 5. So I'm going to say that the tan of theta is the opposite, which is root 5, over the adjacent, which is a root 20. So we know that root 20 is the same as 4 times 5, which is 2 root 5. Okay, so root 5 over 2 root 5, this cancels that. That gives us a half. So tan of theta is equal to a half. And then can we show that the equation of AB is negative 2x minus 1? AB. Okay, so since we got the tan of theta to be a half, remember we say that m is also the same as tan of theta. So this half also represents the gradient of this line, because this is a theta also, in as much as this one is also a theta. So the gradient here, we're getting it as a half, so which means we can get the gradient of AB. These two lines are perpendicular, which means the products of the gradients must give us -1. So I'm going to say a half multiplied by the gradient of AB must give us -1. So gradient of AB becomes -2. Then y minus y1 is equal to m into x minus x1. Which coordinates am I using? They want the equation of AB. Let me use -1 and 1. So it's going to be y minus 1 is equal to -2 into x minus -1. Open this up. That's going to be -2x minus 2. Move the one that side. It's -2x minus 1. So that is how we would have showed that. So that is 4.4. And then 4.5, they want us to get the coordinates of A. Coordinates of A. All right, how many marks is this question? Question is 4 marks. Okay, we can solve the two simultaneously. Since we have the equation of this line, which is -2x minus 1, we can find the equation of this line since we have the gradient. And then we create the 2 and then we're good to go. So what we're going to do, or what I'm going to do, I'll say that the gradient of BF is a half. And then one set of coordinates on this point is -1 and 6. It's going to be y minus 6 is equal to a half into x minus -1. So y is going to be a half x plus a half. Okay. I'm saying a half x because x minus -1 is giving us just a half. And then if we take the 6 that side, it's going to be +6. Okay. So that's going to be a +6. So which means the equation is going to be a half x plus 13/2. Now, this is the equation of DF. The equation of AB is say -2x minus 1. Okay, y is equal. So let me just equate the two and say -2x minus 1 is equal to a half x plus 13/2. Move this one that side. -2x minus a half x is equal to 13/2 plus 1. So 2 plus a half is -2.5. So it's -5/2. The -5/2x is equal to, I simplify this, I have 15/2. Cancel the 2 out, then our x is going to be -3. So if x is a -3, we can substitute this into that equation and get the value of y. So it's going to be -2 times -3, which is a 6 minus 1, which is a 5. So the coordinates of A are -3 and then 5. Okay, so that is 4.5. Then let's see, do we have a 4.6? Yes. They want us to get the ratio of ABC to the ratio of ODF, just the areas. Ne? So let me look at ABC. So if I focus on ABC, this is going to be my base. And then this √5 represents the height. Okay. So that's going to be, let me just break it down, area of ABC. It's a triangle, so it's a half times the base times the height. So half times root 20, we said root 20 is the same as 2 root 5. Okay. And then our height is also a root 5. Okay. Then, if I simplify that, this root 5 and 5, that's a 5 times 2 is 10 divided by 2, which gives me 5 units squared. Then for me to get the area of ODF, the big triangle, I need to get this distance to be my base. And then I know that my height is a 6. Since the y, no, it's not a 6. It's not a 6. I need to find my y here. Okay, because that 6 is for the point C there. So what I'm going to do, let me get the equation of df. Okay, the equation of df, we agreed that it's a half x plus 13 over 2. Okay, a half x plus 13 over 2. Okay, if I equate this to 0, which means my x is going to be 13. Okay, so which means this point is 13. If this point is a 13, which means our base is a 13, and then the y intercept is going to be 13 over 2. So that's going to be area of ODF. That's a half. The base, we said 13, and then times 13 over 2. Simplifying this, I'm going to get 169 over 4. Okay, so that is 169 over 4. Then since we want the ratio of ABC over ODF, that's going to be 5 divided by 169 over 4, which becomes a 20 is to 169. Okay, 20 is to 169. So we can't simplify this any further. So this becomes our answer. Okay. Then that is 4.6. And I think it's the last one for question number 4. Then let's look at question number 5. Question number 5, I think I'll just work it out there since there's space. So simplify this into a single trig sum. So we know that 180 plus is in quadrant 3, and in that quadrant, the sign is negative. So it's going to be negative sine x, but everything is squared. And then the negative angle of sine is the same as negative sine of that angle over sine of 90 plus, that gives me a cos x. These are complementary angles. And then I know that tan is the same as sine x over cos x. We are subtracting a 1. Okay. And then let's cancel what needs to be cancelled. So this cos can cancel that cos. This sine can cancel that sine. The negative and negative will give me positive. So this gives me sine squared x minus 1. Then which trig ratio is this? I know that sine squared x can be written as 1 minus cos squared x minus 1. This cancels that, and we get an answer of negative cos squared x. Alternatively, what you can do here is take out the negative sign. You'll be left with 1 minus sine squared x. And this becomes a negative cos squared x. 6 marks, done. So most of the marks will be given within the reductions here. You have something like 4 marks there. Okay. And then 1 mark there, and the other mark would be somewhere there, or the simplification. All right, 5.2. They want us to use the cos of a minus b, which is given as this, to deduce this kind of expression. So what I'm going to say, or what I'm going to do, is I know that the sine of a plus b is the same as cos of 90 minus a plus b. I don't know if that makes sense. Would that make sense? the sine of 90 of that, okay? Then I can expand this and say this is my cos of 90 minus A. And you put these brackets, 90 minus A, and then minus B. And then I can do the expansion here using what we were given. So that's going to be cos of 90 minus A. Okay. And then the cos of B plus the sine of 90 minus A. And then the sine of B. So we know that cos of 90 minus will just give us the sine of A. And that is a cos B. Then this is going to be, let me put a plus for now. The sine of 90 minus is going to give me a cos of A. And then that is the sine of B. So this is what they needed. It's basically what they have there. So that's how we would have gone about this question. Then 5.2.2. So since we do it using compound angles, which means even this should be using compound application. So 420, let me just break this down. So 420 is in the first quadrant, which is a 360 plus 16, then cos 15. Sine 300 is in the fourth quadrant, which is 360 minus 60. And then 105 is in the second quadrant. I cannot use 180 because that's going to give me something like a 75. Okay. Let me use 90. If I use 90 plus 15, I'll get the 105. Okay. The reduction of 360 plus, that's going to be cos of 60 multiplied by the cos of 15. Okay, so the cos of 90 plus 15, that's going to give me a negative sine 15. Okay, so this is going to be a cos of 60, cos of 15. This and that will give me a plus sine 60, and then the sine of 15. So it's a compound angle of cos. So which means it's going to be the cos. What is 60? Is it a minus or plus? That's going to be 60 minus 15, which is the cos of 45. And the cos of 45 is the same as 1 over root 2. So that would be the answer if we don't have a calculator. Alternatively, some people would have a root 2 over 2. Nevertheless, that should be how this question should be approached. Then 5.3, given tan squared x into 1 over tan squared x minus 1. Can we prove this? So let me start from the left-hand side. I'll start by opening through. So I'll have tan squared x over tan squared x minus tan squared x. Okay, so this is going to give me just a 1 minus, I can change that to a sine squared x over cos squared x. Do the cross multiplication, find the LCM. So that's going to be cos squared x minus sine squared x over cos squared x. Okay, so I know that if I have a cos 2x is the same as cos squared minus sine squared. Okay, so automatically I have my cos 2x, then over cos squared x, which is equal to the right-hand side. It's 3 marks, which means it was just a bit straightforward. Then for which values of x in the interval of 0 to 180 is this expression undefined? So one thing we know is that an expression will be undefined if the denominator is equal to 0. No? So I'm not going to look at the entire expression, but I would rather look at this simplified format of it. So I'm going to look at the denominator. Which denominator? Is cos squared x. Okay, so when do I have the cos squared x to be negative, to be a 0? Okay, So I'm saying cos squared x to be a 0. You can find the square root, and then you shall have the cos to be a 0. So x is basically 19. That's what I have, because cos of 0 is going to be a 1. And then the cos of 180 is going to also be something else, a negative 1. So there's only one value, which is 90. Okay. And we know that even tan is undefined at that point of 90, where the graph will have an asymptote. All right, then 5.5 next, 5.4. 5.4. What's happening with my 5.4? They want us to find the general solution of the equation. Okay, so we have cos 2x is equal to the cos of x. So the easiest way to do this is by breaking down this cos 2x, this double angle of cos, into the format of cos. So we said it is cos squared x minus sine squared x. So that's going to be the same as 2 cos squared x minus 1. So let's express this in that form. So it is 2 cos squared x minus 1 is equal to the cos of x. Let's move this that side. So it's 2 cos squared x minus cos x minus 1 is equal to 0. Okay, we can factor this out, or you can use your quadratic formula, no stress. So I'll have 2 cos x. This is just cos x. So I can have a 1 and then a 1 is equal to 0. So since that's a negative, I'll put a negative here, and this will be a plus. So which means 2 cos x plus 1 must give me a 0, which means cos x is going to be negative a half. Alternatively, cos x must give us a 1. So if I look at the negative a half, my reference angle, okay, so the shift cos of a half is going to be 60, okay? But in the second quadrant, that's when cos is negative. So I'll say quadrant number 2, I'll have 180 minus 60, that is a 120, plus k times 360. K is an element of integers. And then which other quadrant is this thing negative? Is quadrant 4. Quadrant 4 is going to be 300, because it's 360 minus 60. Let me put it this side. So negative 300 minus, so 360 minus that is the 300. So 300 plus k times 360, k is an element of integers. When we look at this other solution, cos of x is equal to 1. So the reference angle is going to be the arc cos of 1. Okay, shift cos of 1 gives me a 0. Okay, so which means the other solution is 0 plus k times 360. K is an element of integer. So we don't need to write the 0. You can just say k times that. Then the other solution will definitely be 360 plus k times 360. Is that true? What's the cos of 360? It's a positive one. Perfect. Beautiful. So that is k is an element of the integer. So those are the 4 solutions that we probably expected. No, there's something wrong here. This 300 cannot be, because in quadrant number 4, cos is positive, so it's 2 and 3, which makes this a 240. Yes. So it's a 240, and then that. So those are the solutions that we would have used for that particular question. 5.5. Okay. Given that the sine of theta is a half, calculate the numerical value of sine 3 theta. So there are 2 ways to this, of getting the 7 marks. We can use a simple sketch, if you so wish. Call this a theta. We know that sine is opposite over hypotenuse, so that this can be a root 3. Okay, without using calculator. We haven't used the calculator there. So 2 squared minus 1 under root sine, that is it. So we can have this format, or we can express this entire sine 3 theta just in form of sine theta. So that will be the same as 2 theta plus a theta. Let's expand this using the compound angles. So that's going to be sine. Okay, let's change that. So we're saying it's a sine 2 theta cos theta plus cos 2 theta sine theta. Okay, we know that sine 2 theta can be broken down into 2 sine theta cos theta multiplying by another cos theta plus cos 2 theta will be the same as 1 minus 2 sine squared theta. Okay, let me just put it that way. Okay, 1 minus 2 sine squared theta. Now multiplying by sine theta again. So this becomes 2. We know that this and this is going to be cos squared, which is the same as 1 minus sine squared theta. And then this is going to be plus sine theta minus 2 sine cubed theta. Open this up. I have 2 sine theta minus 2 sine cubed theta plus the sine theta minus 2 sine cubed theta. When you add up, you have 3 sine theta minus 4 sine cubed theta. That is if I want to express everything just in form of sine. And then I don't have to use this triangle. So this is going to be 3 times a half minus 4 times a half cubed. So that's going to be 3 over 2 minus, that's going to give me 1 over 8. 1 over 8 times 4. 1 over 8 times 4 is also going to give me a half. You break this down, it's 2 over 2, which gives me an answer of just 1. So alternatively, what I would have done, instead of me breaking this down and down, just from this step, I would have simplified this to have a 2 sine theta cos theta squared, and then plus sine theta minus 2 sine cubed theta, and then just substitute. So it's a 2 times a half, and then the cos is adjacent of hypotenuse, so that's a root 3 over 2 squared plus a half minus 2 times a half cubed. So this cancels that. I'll have a 3 over 4 plus a half minus, that's going to be an 8, which is 1 over 4. And then 3/4 minus a quarter, you get a half. And then a half plus a half, which gives us a 1. Okay. So that is question number 5.5. No? And then question number 6. Question number 6, let me have it here. Question number 6, they are telling us that in the diagram below, we have f, which is the 2 cos x, is drawn in this interval. On the same grid, they want us to draw the negative 2 cos. So when you punch this into your calculator, using mod, I'll go to table, say mod and table, which is 3. I have negative cos 2x, close brackets. I'm starting from negative 180, positive 180 is the end, and then my step is 45. Okay, so if I look at my drawing, or if I look at the diagram, let me do it this side. So negative 180 is negative 1. Negative 135 is 0. Negative 90 is a 1. Negative 45 is a 0. Then 0 is going to give me negative 1. 45 is going to give us a 0. 90 gives me a 1. 135 is a 0. And then 180 is a negative 1. Then connect these points with your free hand. Now remember, That's a turning point. So it shouldn't really be that sharp. It should be a bit smooth. Okay. So we have that, and then that is our G. Then the next question, they want us to write down the period. So when you talk about period of 2G of X, so if G of X is given as negative cos 2X, so where there is X, I'm going to replace it with X plus 10. Okay, so that's going to be negative 2, okay, cos of 2 into X plus 10. That has no effect. Okay, so the only effect or impact we have is this 2. This 2 and that will give us a 2x, which 2x affects the period. So get 360 divided by 2, which is 180. Alternatively, what we can see is that we have two graphs of cos in this interval of 360. So after 180, we have one graph of cos. The rest is just a shift. Then 6.3. Use the graph to determine the values of x in this interval between 0 to 180, where f of x, g of x is less than 0. Okay, between 0 up to 180. They told us f of x times g of x is less or equal to 0. Now, what this means that either f can be above the x-axis and g can be below. Alternatively, f can be below and g is above. So I can see g is below, okay, while x is above, just between 0 and 45, between 0 and 45. So I'll say that 0 is less or equal to x, less or equal to 45. That is scenario number 1. Scenario number 2, where f is on top and g is below. So from 90 up to 135, you can see that g is above. And then 90 up to that, this one is below. So I'll say 90 is less or equal to x, and then less or equal to 135. So that is what we were meant to do in 6.3. Then 6.4, determine the maximum value of f of x minus g of x. So when we say f of x minus, it's like the difference between. When I subtract at this point, I have just a 1. Then here I have something like 1,5. Then here it's a 1, that's a 1,5. And then I think this is the biggest difference between the two graphs, okay? So this is 2 units and then plus 1 unit, which gives us 3 units. How many marks is it? 3 marks. That's like 3 units. No? It's 1 mark for 3 units. All right, then next 6.5. They want us to get the range of y is equal to 2 cos x plus 2. So 2 cos x, remember that is the f, okay? Now the moment we say plus 2, which means this graph is being shifted 4 units upwards, okay? So no, it's 2 units upwards. Okay, so which means the new turning point will be at a 4. Okay, and then this is going to be negative 2 plus 2, which is going to be 0. So we can say that the range of 2 cos x plus 2 is basically 0 less or equal to y less or equal to 4. That is the top part. But then if we have now the exponent involved, so which means the range of 2 cos x plus 2 is going to be the same as 2 to the 0. I need to be liberated if I'm going astray. Okay. Is that 2 to the 0 or 2 to the 1? Let's go back. Let's go back. We're talking of f. Ne? This is f. This is f, we're moving 2 units up, 1, and then 2 upwards. Let's just confirm the question. It's a plus 2. Beautiful. So if it's a 2, which means it's going to be at a 0. And then if it moves 2, that's 4. So which means I'm going to have 2 to the 0 is less y less 2 to the 4. That's a 1 less y less 16. So this will represent our new values. Okay. We can't say otherwise. It's 2 units. 1, 2. Beautiful. So this is going to be the range that they need, 1 and 16. Okay, then 6.5 will be the last for question number 6. We'll look at question 7, which is the 2D, 3D trig. Okay. Question number 7. I'm telling us that in the diagram below, we have 2 vertical poles, AB and BC. Point E lies in the same horizontal plane as the bases DC. The poles, they gave us all these values. Beautiful. That's why meters. Then the first question. Can we express BE? BE in terms of alpha and y. BE, this distance. So if we look at this is a right angle triangle. We can use our trig ratios. So this is the opposite, this is the hypotenuse. So we can use the sine and say sine of alpha is equal to the opposite over the hypotenuse, which is a BE. Make BE the subject, which should be y over the sine of alpha. So that is 7.1. Then 7.2. 7.2. So I said y over the sine of alpha. Let's look at 7.2. Can we show that AB is 2y for 5 marks? They want us to show that this is a 2y. So what we can do, let's start by finding this angle here. Since this is a triangle, we can say that this angle BAE, the Bay angle, it should be 180 minus the 90 minus 3 alpha. Minus 2 alpha also, no stress. So it's 180 minus, that's 90 minus alpha, which gives me a 90 plus alpha. The reason for this will be angles in a triangle. Okay, so if this is 90 plus alpha, I have this side and then I have to look for AB. So I can use the sine rules. Okay, then I'll say that what I'm looking for the side. So let me start with the side and say AB over the sine of AEB is equal to my BE over the sine of B. Let's substitute. AB is what we want. It's going to be the BE, the sine of AEB, over the sine of B. When we substitute that, so our BE, we said it's y over sine alpha. We're multiplying it by the sine of AEB, which is twice alpha. Everything is divided by the sine of B, which is 90 plus theta. No, 90 plus alpha. All right, so we simplify this. So I'm going to break down this sine 2 alpha so that I have y into 2 sine alpha cos alpha, but I'm dividing this by the sine alpha, the sine alpha here, over, when I use my reductions, 90 plus will give me the cos of alpha. So this sine cancels that sine, this cancels that, then I'll be left with 2 times y, which is a 2y. Okay, so that is the approach for 7.2. Then 7.3. 7.3. If it's further given that AF is 7 over 4 BC, AF, let's do this. Where is AF? This distance here is 7 over 4 BC. What is our BC? Our BC is y. So this is 7 over 4 y. We just showed that AB is twice y. What is the question asking for? They want us to give the angle of elevation BAF, 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 this angle here. So we can use, since this is a right angle triangle, we can get what we call it? Okay, so we said we're gonna use the trig ratios. So if this is our BAF, we say this is 7/4y, this is a 2y. So we can use adjacent hypotenuse, the cos. So the cos of BAF is equal to adjacent 7/4y divided by 2y. So the 2's will cancel out, and then BAF, the cos, should give me something like 7/8. Then which means BAF will be the arc cos of 7/8. Okay. When I punch this into the calculator, okay, 7/8, what we get? Well, we get 29 plus 28. I'm getting, let's see, that's going to be 28,955, but the question said nearest degree. So which means it's a 29. Okay, that is 7.3. And okay, the closure of 7. Let's look at question 8. Wow. The diagram below the circle passes through the points A, B, C, and D. Okay. AD is a diameter, which means there's a center somewhere there. And then BD and AC intersect. BD and AC intersect at a point H. And then this angle is 58. What do they want? They want us to get the size of B2. Okay. So for me to get B2, what I can see is that this angle here, for as long as we've just agreed that AD is a diameter, then that's going to be a 90, because this triangle is touching the ends of the circle. So it's saying, I'm saying, let me put it aside. Say B2 is going to be a 90. It's saying angle in a semicircle. Okay, so that is 90. Let me just put it nicely here. Then they want us to get B1. Let's see what's happening with B1. Where is B1? B1 is this one here. All right. So what I'm going to do, if I look at A, B, C, G, it's going to form a cyclic chord. So I can start by finding this entire angle here. Okay. Then if I have the whole of B, I can get now B1. So I'm going to say B is going to be 180 minus 58. The reason is going to be opposite angles of a cyclic chord. Okay, then that's going to give me 122. Okay, so if B is 122, but B2 is a 90, which means B1 is going to be 122 minus 90, which is a 32. Okay, that becomes a 32. So if B1 is a 32, we agree. If B1 is a 32, they want us to get A2, this angle here. So we know that A2 is also going to be a 32. Angles in the same segment, because we can see the bow tie that is formed. So that is also a 32. The next, what do they want? They want that if it's given, let me just use this one. Okay, so if it's given that AB is the same as BC, okay, AB is the same as BC, where is AB? This one is the same as this one, okay. And then can we prove that AB is a tangent to a circle that is passing through AHD? Okay, we say AHD. Let me draw my circle here. What type of circle is this? Okay, it's fine. We don't care what type of circle it is. Let's see if we can have our AHB. So if we have a circle, we'll do that now. Didn't do that. So a circle like that with a sharp point. Okay, guys, let's assume that's our circle of interest. They want us to prove that AB is a tangent. Now, the information that they gave us is very, very, very important, that those two sides are equal. So it simply means that this angle A3 should be the same as C1. Okay. Do we know those angles A3 and C1? We don't know. Let's get them. Okay. So we're going to say that A3 and C1, let's get, but why should we go through that? Okay, it's 122. It's 180 minus 122 divided by 2. The reason is going to be angles opposite equal sides. Ne? So that's 58, which gives me a 29. Ne? So if that is a 29, it simply means that A3 is a 29 and then C1. A3 equals to C1 equals 29 because of the condition they gave us. Now let me use this 29 to find this angle here, D. Okay, because now my focus is now on this big triangle, ABD. Okay, let me get the angles in the triangle. This is a 90, remember? This is 32 and 29, which gives me a 61. Eh? So I'm going to say that D is going to be 90 minus 61, which is 29. Now, since our A3 is the same as D, okay, therefore AB is a tangent. What I'm saying is that if we look at our drawing, if this is a 29, and we say this one is also a 29, this becomes a tangent because it will form the tan chord within that circle of ours. Okay, so it's a tangent, the converse of the tan chord. So that's how I would have approached 8.2. Okay. Then question 9. Question number 9. We were given this drawing with the center of the circle, points S, T, and R lie on the circle. QS is a tangent. Use the theorem to prove the tan chord theorem. So step number 1, you have to do the constructions, please. So our constructions, I'll just make it pass through the center. Let's call this M. And then let's connect this to that point. Okay. So feel free, remember it's a construction. And with the construction, you can even be allowed to label in your own format. So I can call this 1 and 2. I can also call this 1 and 2. No stress. Okay. Then having done that, we can say that MRS is going to be 90 degrees. Reason, angle in a semicircle. It's an angle in a semicircle. If that is true, which means we can get R2, which is going to be 90 minus R1. We can call this our first equation. And let's come down here. I'm going to say QSO is also 90. The reason is going to be the tangent must always be perpendicular to the radius or the diameter. And then, which means that my S1, let me find S1. It's going to be 90 minus S2. Reason, these are adjacent complementary angles, the same as the equation 1. I'll call that equation 2. And then I'm going to put a but and say that my angle S2 is the same as which angle? Is the same as R1. So this angle is the same as R1 because of the bow tie. Okay. The reason is saying angles in the same segment. Angles in the same segment. Okay. So we're saying S2 is the same as R1. So where there is S2, I can replace most with R1. So S1 is going to be 90 minus R1. And we're seeing that this is the same as the first equation of interest. Okay. That is going to be the angle of interest. Okay, so since we've proved that S1 is the same as the 90 minus R1, which is our R2. So S1 is the same as R2. Therefore, you just draw the conclusion that QST is the same as angle R. So that is the proof for the 6 marks. The statements and the reasons play a big role. Okay. Then question number 9. Question number 9. They're telling us 9.2 that in the diagram below, DEF are points on the circle, and as a center Q, that line is a tangent to the circle that is produced to meet tangent AB. C are points on AE such that these two lines are parallel, beautiful. GC is joined. And then let's pay attention to this. GCDF. Okay? GCDF. They told us it's a cyclic quad. Okay, and then this is 2x. First question. The first question is, can we give reasons why E is x? So why is this angle x? So this angle at the center, that's the angle at the circumference. So we're going to say that angle at the center is twice angle at the circumference. So that will be my explanation for that. Then 9.2.2. Can we prove that GC is parallel to FE? Prove that GC is parallel to FE. So what I can see is that they want us to prove that these two lines are parallel. If this is x, which means F1 is also going to be x, I'm going to use the turn chord theorem there. And if that is x, remember they told us that this is a cyclic quad. It's this side. This is a cyclic quad. So if that is x, automatically this is going to be 180 minus x. So I'll say that C2 is going to be 180 minus x. These are the opposite angles of a cyclic quad. Okay, so if this is 180 minus x, I can see that C2 and E, when I add them, I get 180. So those form what we call the co-interior angles. So we're saying C2 plus E, which is 180 plus x minus x, gives me 180. Therefore, GC is parallel to FE. Reason to be the converse of co-interior angles. All right, so that is how we were going to prove that. Use the cyclic quad and then the co-interior. Now we've proved that these lines are parallel. Okay, we've proved that the lines are parallel. Now they want us to prove that AB over that is the same as that. So let's. Okay, 9.2.3, I want us to prove that. So what I'm going to do, I'm going to say that my AG. Okay, so AG over GF should be equal to AB divided by BD. That is the proportionality theorem. Okay, because GB is parallel to FD. Let me look at the bigger triangle since we know that these two sides are also parallel. So if I have AG over GF, should give me AC over CE. So same reason, proportionality theorem, because GC is parallel to FE. Now, since both have AG over GF, I will equate both and say AB over BD should give us AC over CE. So that is what the question wanted. And then 9.2.4, they're telling us that if it's further given that our AB is 12, okay, AB is 12, CE from here up to there is 22.5, and then they gave us this ratio. Let's simplify that. So if we have AG over GF, That's going to be 4 over 5. So if that is 4, then this is a 5. I want us to find the distance, CD. So from the ratios that we had earlier on, let's just use them and see. So AG over GF should give us, let me say AB over BD. First of all, let me have this as my X. Okay. AB over BD. No, let me get the whole. Don't worry about the X. So our AG is 4 over 5 is equal to AB, which is a 12 over BD. Let's cross multiply. So BD is going to be 12 times 5 divided by 4, which gives me 15 units, which means from B to D, I have 15 units. Then let me look at that other triangle, the big one, where I have AG over GF is equal to AC over CE. Okay, so if I do my substitution, our AG is 4 over 5. Our AC, I'm going to say now it's a 12 plus X over CE, which is 22,5. Let's look for X. So it's going to be 4 times 22,5 divided by 5, then we subtract the 12. This gives me 6 units for X alone. Now remember we said BD is 15, BC is a 6, so we can find our CD, which is 15 minus 6, which is basically 9 units. All right, then question number 10. They're telling us we have this diagram, KHG, there's a point on the circle, we have tangents, the circle, there's a semicircle, and all of that. They want us to give a reason why DC and CE are equal. So we know that both these lines are tangents, but for as long as they are coming from a common point, then the tangents must be equal to each other. So the reason here is going to be tangents from a common point. Okay, those are tangents from a common point. So that is equal to that. Then they want us to prove that DCE is similar to HEK, DCE. So what we can know, or what we can see, is that this E2 is going to be the same as C. Okay, so E2 is the same as C. Those are alternate angles because EH is parallel to BC. Okay, that we know, we've stated. Now, what we can see is that as much as these two are equal, so if this is also E2, then this angle here is going to be the same as that. So I'll say that E1 is the same as D. These are angles opposite equal sides. Okay. And then also from this triangle, I can say that EH is a radius and EK is also a radius, which means that K1 must also be the same as H. Those are still angles opposite equal sides. But now, if this is the same as that, and this is also the same as that, if I were to call this E2, which means this angle here will be 180 minus, we have E2, and then we divide this by 2, which would be 90 minus a half E2. So 90 minus a half E2, same applies to this, 90 minus a half E2. So same story here, if this is E2, then even this one is going to be 90 minus a half E2, same as K1 also. So if that is true, then we can just go ahead and finish up the proof and say that our D should be the same as angle H, and then our E1 should be the same as K1. Now remember, we started with the alternate where we said E2 is the same as the angle C. So those are 3 fundamental facts, and then draw the conclusion. Therefore, BCE is similar to HEK. because of angles. Ne? So that is how we would have claimed those 6 marks. So remember, all started here, the alternate angles, angles opposite equal sides, and trying to find those missing angles. So if that is true, and then we have 10.3, where they are telling us to prove that DG is the same as GE. DG is the same as GE. So if this is a radius, as we stated, even this is a radius because of sides opposite equal angles, which means that even GE is a radius because from the center to the circumference of the circle. Now, since this is a tangent FG, which means that this angle here is going to be a 90. So let's start with that and say that FGE. Okay, let me just put it this way. Saying FGE is 90. Okay, we said FGE is 90. Reason, the tangent perpendicular, the radius. Yeah? And if this is a 90, then we know that this F is the center of the semicircle. So a line from the center of the circle that is perpendicular to the chord must bisect the chord. So we're just going to write that reason. That the line, I'll say FG, line FG from the center of the circle and then perpendicular to the chord, which chord is DE, will bisect it. Bisects the chord. All right, so that is what they needed. So therefore, DG is the same as GE, which is also a radius. So that is R. This is also R. Okay, then next question. They want us to show that 2HE squared is equal to that. So let me try to draw my triangles based on the corresponding sides and angles. So if this is our DCE, okay, DCE, then this is gonna be EH, and then K, because they said DEC is the same as HKE, HEK, okay. HEK. Okay, so let's have it that way because we know that these angles are basically the same. So this is what is common to that. Let's replace the radius. So DE is going to be twice R, but we said HE is a radius. Okay, that's a radius. So let me compare the sides by saying that if I have my DE, let me erase that and say if I have my DE divided by my HK, this must give me the same as having a DC divided by HE. Okay, so I'm going to say sides in proportion, because DEC is similar to HEK, or you can just give us the last part. Those triangles are similar. Okay, if we do the cross multiplication, we have DE multiplied by HE is equal to DC multiplied by HK. Okay, so we have the DC and HK. But we know that DE is twice of R, and of which R is the HE. So we're going to have twice of HE times HE should give us DC multiplied by HK. Okay, remember we said that